Here's another interesting example that you might see. Y equals 3x minus 2 and y equals 5x plus 6. So the question is, which of these equations do we use to start with? It really doesn't matter which one we pick. They'll take us to the same road either way. So I could say, here is an equation solved for y. I'm going to take 3x minus 2 and put it in place of this y right here. That's going to give us the equation 3x minus 2 equals 5x plus 6. But what if you saw it the other way around? What if you spotted the second equation and said, here's a 5x plus 6 that I'll put in place of the y right there? It's getting us to the same equation. We see that the sides have been flip-flopped, but they're both stating that 5x plus 6 and 3x minus 2 are equal. And even a third way you could think about a problem like this is, well, if 3x minus 2 equals y and 5x plus 6 equals y, if they both equal y, then they have to equal each other. It's like if you share the same birthday as Tom and I have the same birthday as Tom, we must have the same birthday. Same idea. So two things equal y, they got to equal each other. So however way you look at it, any way you slice it, we're getting to an equation like this one right here. And now let's work to solve the equation. I'm working to get the x on the left side and constant to the other side, the right side. So I will take away 3x from both sides. And at the same time, I'm going to take away 6 from both sides. I'm getting the term with the variable off the right side and the constant off of the left side, both at the same time. Feel free to try it at home. So the 6 wipes out the negative 6, 3x minus 3x. Carefully, what are we left with? 2x equals negative 8. And if you did that process in a couple of steps instead of just one big step, we should be getting to the same spot. 2x equals negative 8. So we're going to finish solving for x, divide both sides by 2. X equals negative 4. Now let's find our y value. Take negative 4 and substitute it in place of, well, here's the question. Where do we go? And again, it doesn't matter. Do I substitute negative 4 in place of this x or in place of this x? It doesn't matter. It's going to give us the same answer both ways. That's how this whole system works. But I'll show it to you anyways. So if we took the top equation, y equals 3x minus 2, plugging in the negative 4, we would have 3 times negative 4 minus 2. Order of operations gets us to negative 12 minus 2, then negative 14. Y equals negative 14. And if I chose the second equation to substitute into 5x plus 6, 5 times negative 4 plus 6 gets us to negative 20 plus 6, and then negative 14. Same result both ways. So it doesn't matter how we spot the substitution initially. Maybe what I'd prefer is to say if they both equal y, then just set them equal to each other. And it doesn't matter which one we choose to substitute back into. It's actually even a good way to check that we did the first part correctly, that it does have to give us the same thing in both equations. If it didn't match, it means that we found a wrong answer initially. So there's the rundown with a type of system you see where they're both solved for y or both solved for x. No huge difference.